Python is one of the most important programming languages for machine learning. This is because of its simplicity and an extensive ecosystem of libraries. Python is also open source, and it has got an active community which is constantly developing the language as well as the libraries. So Python is one of the best choices for both beginners and advanced practitioners who want to work on machine learning. This lab tutorial introduces the foundational concepts of Python programming with a focus on geospatial analysis and machine learning. So we are going to look at things like variables, data types, basic operations, data structures. We're also going to look at functions, modules, and libraries. So let's get started. So first of all, what are variables? Variables are containers that are used to store data values. Okay, these allow you to work with these variables later in your program. Okay, so how do you create a variable? You create a variable just by assigning a value to a name. Okay, so we can use the assignment operator to assign the value to a name. For example, here below we have our variable called country name, and to this variable we are going to store the value which is a string called the string is the name of the country. Here is Zimbabwe. Okay, so the country name here is our variable, that is the container that is going to contain the name of the country. Right, so there are a number of things that need to take into consideration when you're naming variables. Okay, so this is very important for clarity and maintaining coding standards. First, you need to choose your name that you can clearly describe. Okay, the name should serve a purpose. For example, when we are doing machine learning for land cover mapping, we usually define the variables such as a land cover type. So you can see someone can really understand what this stands for. And also, it's also important to use, for example, lowercase letters, which can be separated by underscores for readability. Okay, or you can just use a lowercase in the beginning, and then you have another word with an uppercase. So this is quite important. And you should also avoid to use the Python keywords or built-in function names. For example, using words like print, class, or object. And it's also good that the variable names begin with a letter. Okay, between it could be lowercase from A to Z, or uppercase A to Z, and also using underscores, as I said below. Okay, be careful, you should not start with a number. Okay, variable names also can include letters, numbers, and underscores. Okay, but no spaces or special characters. And it is good to maintain consistency throughout your code, so that your other users can read the code without any difficulties. Right, next we are going to look at data types. So the data types in Python define the kind of data a variable can hold. So there are different types of data types in Python. So we have integers, we have floating point numbers, we have strings, we have the boolean. Python also has got a lot of support for complex data types such as the lists, the tuples, dictionaries, and so forth. Okay, so integer, what is an integer? Integer is just a whole number which can be either positive or negative. So it doesn't have any fractional part or a decimal part. For example, here we have our variable age, and it's holding a whole number 25. Okay, so this is an example for integer. So if we click this one, okay, we are going to have the age. Okay, so this is the whole number. Okay, so a float represents a decimal point. Okay, so for example, elevation, we have here 5.8. Okay, and then a string represents a text in Python. So strings can include letters, numbers, and symbols. Okay, and the strings are enclosed by single or double quotes, but don't mix the two. Okay, for example, here we have assigned the name here Harare, okay, which is a string, to our variable the city. Okay, so this is a string. Right. One important thing also is that we can also have multi-line strings in Python. So these are very important. For example, when you want to write a very lengthy SQL query, or you want to write a multi-line text. For example, I want to write this multi-line text. I declare my variable here, info. So for example, I want to say, what is the capital city of Zimbabwe? Okay, and then the answer is the capital city is Harare. And where is the capital city of Zimbabwe located? And so forth. So if I print this statement, it's going to produce this kind of response. So it's quite ordered. So this is one way you can use the multi-line string. Sorry. Right. Next, we have a boolean. So a boolean just represents one of the two values. For example, true or false. For example, we can have this kind of code where we want to check if a point lies within a certain boundary. Okay, so for our variable here, where is within boundary, and then is it true? So if the point is within the boundary, then it's going to print true. Okay. So we can also use this later in the logical operations that I'm going to explain. But for example, if it is within the boundary, then we can say the location is valid for analysis. Else, it is outside. Okay, so this is the use of the Boolean data type. Okay, next, let's look at the basic operations in Python. So basic operations include the arithmetic operations. Okay, so arithmetic operations where we can do the addition, subtraction, multiplication, and division. And we also have the comparison operations and logical operations for conditional expressions. Okay, so for the basic operations, this is quite simple. As I said, we have the addition, subtraction, multiplication, and division. For example, here we can just have a simple addition, 5 plus 3, and then we get our answer. We can also use these basic operations for in particular the arithmetic operations. For example, to calculate the total area or average area of several countries. For example, you have an example of calculating the land areas of the countries that are below: Zimbabwe, South Africa, Botswana, Namibia. Okay, so here we have our variable which have defined land areas. So we have the land areas. So now if we want to do arithmetic operations. For example, get the total number of the land areas in these countries. We can just call, you can just use this function sum, and then we get the land areas values, and then we assign that value in the variable total area. And then to get the average size of these countries, so we are just simply going to create the average underscore area variable, and then we are going to get the total area, and then we divide by the land area, and then we can print this. So if we run, we can just get our answers here. So these are just the arithmetic operations. And next we have the comparison operators. So these are used to compare two values, and then they can return a Boolean result. For example, true if the condition is met, or false when the condition is not met. So these include these operators such as equal to, not equal to, as well as greater than, less than, greater than or equal to, less than or equal to. So this is just for comparing magnitudes. Let's take, for example, the list of elevations that for different locations. So I've just come up with these numbers, and say we want to check if these numbers fall under or above the threshold that I've just defined. So the threshold is 1000. Okay, so we can use the operators to check that. Okay, so here we have just created a variable above threshold. Okay, so it shows that if elevation is greater than the threshold, then we are going to get values above the threshold. We can use also to compare between the maximum elevation. For example, our highest elevation, we get the maximum elevation, and then we can create a variable is highest extreme, and then we just say if it's extreme, it is greater than 2500. Then we can run the code, and then we can print the results. So here we have our elevations. Threshold is 1000 meters, and then the locations above the threshold. If we look at the numbers, as you can see, the first one is below, so it's false. Second one is above, true. The third below, false, and so forth. Okay, so this is just one example of the comparison operators. Right, next we are going to look at the logical operators. And here for the logical operators, we have three operators, and, or, and not. So these are used mostly when we are doing we want to look if conditions are true or conditions are false. Okay, so for example, let's look at this. We have geographic data. Okay, we have an elevation for 800 and then temperature of 22 degrees Celsius. So we want to do a suitability analysis. So the criteria is as follows. So the first criteria is suitable elevation. So the elevation is greater than 500 meters, and the elevation is less than 1500 meters. So elevation is between 500 and 1500 meters. Then is suitable temperature. Okay, again, we are going to look at the elevation, the temperature, which is within a comfortable range. For example, between 15 and 25 degrees. And then is not extreme. Okay, so we are just looking at not the extreme conditions. For example, elevation which is greater than 3000 meters, or a temperature which is less than 0. Okay, so we can do this. We can now check the suitability. Okay, so first the suitable elevation. We look at suitable temperature, and then not extreme condition, and then we look at which location is suitable. So if we run, we can see, okay, if it is say according to our criteria, if it is between 500 meters and 1,500, then the condition is true, it's suitable. Okay, so this is just how you can run your logical operators, because these are just simple examples. You can explore more examples in the exercise that we provide later. Right, next we are going to look at control structures, which are very important for developers who want to control the flow of a program. This is very important because we have the conditional structures, and also the loops, which are important for executing repetitions. Right. Let's say we have this example again. We want to do a classification of, say, landscape based on elevation or altitude in meters. So we have our elevation here, the elevation values. So now we want to create a code which can categorize the landscape according to the elevation. So so we start with for elevation in elevations. If elevation is less than 500 meters, then the landscape is categorized as lowland. If it is greater than, if it is less than or equal and less than 1,500 meters, then it is upland. So if it is between 500 to 1,500, it's an upland. And then if the elevation is between 1,500 and 2,500, then it's highland. Else, if it is doesn't match this condition, then it is categorized as a mountain. So if we run, we can now check that all elevations that are less than 4,000, that are less than 500, they are lowland. Okay, so this is now getting our values here. Okay, those above between 500 and 1,500 is an upland. Okay, lowland here again, this is less than 500. And the upland between 500 and 1,500. And the highland, it's between 1,500 and 2,500. And finally, above 2,500, this is just a mountain. Okay, so this is just how we can use the control structures. Okay, and this is one of the Python tools that we are going to use a lot. For example, when we are going to do the reclassification of land cover classes. For example, if you want to reclassify some of the land cover classes, multiple land cover classes, into binary classes, for example, forest or non-forest. So you can use this kind of code to do that. Right, and next we are going to look at these complex data structures. We've got here list, dictionaries, and tuples, and these are quite important because they can be used to organize and store data very efficiently. Okay, so we start with a list. So a list is just a collection of the ordered items, and these items can be modified even after when you create the list. Okay, so lists are defined using the square bracket. Okay, so if you see the square bracket, that means this is a list. So important features is that the elements in the list, they are in the order they are added. And number two, you can modify them. That is, you can add, remove, or modify the elements. You can also allow duplicate elements in the list. So let's take an example of here the list of cities in Zimbabwe. So we have Harare, Bulawayo, Mutare, Gweru. So these are the cities. So we can modify this list by just adding another city. So if we use this cities.append, okay, this method, then we can add the list. Okay, so if we run, so first we can also print the second city is Bulawayo, and then all the cities, including Victoria Falls, that we have added, we can see them in the new list. So lists are quite important, just to add new values or anything that you want to include in your code. Okay, then we have the dictionaries. So dictionary is just a collection of key value pairs. Okay, so here we have each value which has got a key which is unique. Okay, so each key maps to a value, and the dictionaries are defined using the curly braces. So this is a distinction between the list and the dictionaries. So what are the important features of dictionaries? So the elements here are not stored in a specific order. Okay, and you can also add, modify, or remove key value pairs. However, here duplicate keys are not allowed. Right, so let's take an example of the cities that we have seen, the cities of Zimbabwe. So we have this variable city underscore population. So we want to list the population of the cities. Okay, so the first city, Harare, 1.5 million, and we have Bulawayo 650,000, Mutare 300,000, Gweru 160,000. And here I've just formatted this so that we can get the dictionary in decimal places, right? And one important thing here, you can notice that I'm using here the formatted string. This F means this is the formatted string. This is because I'm mixing here the text and values. Okay, I'm mixing the text and values. For example, here in the curly braces, the city, here will be printing the city and then its population. So you can see here the city and its population. Okay, and again, as I've said, this the dictionary, you can modify it, or you can add or remove a key. Okay, so this is the character of being mutable. So again, we have added the city of Victoria Falls, which is not available in the original list. So if we run this code, we can see that we have the original list. Okay, and then we have the updated list with the Victoria Falls. Right, so this is the dictionaries. Okay, so important things to note here. Okay, the dictionaries, they are not ordered. However, they are mutable, and the keys are just unique. You cannot duplicate them. The next we have the tuples. So a tuple is an ordered immutable collection of elements. So this is quite important. It's ordered, but the elements cannot be modified after creation. Okay, the tuples can contain duplicate elements, and these are quite important because they are quite efficient, because they consume less memory, and then they are faster than the list. Right, so we can use this, for example, to store coordinates which do not change. Let's take an example here. We have these coordinates, coordinates and elevation. Okay, and if we run this, for example, we can see that we have our coordinates here, and then we have our elevation printed in this example. But this is just an example for tuple. So these are quite important. For example, if you have things that are not going to change, okay, like coordinates or elevation. So if you want to store those kind of values, you can use that. Right. Let's move on next to writing and importing functions and modules. So these are quite important. So functions and modules are very important again for organizing and reusing code. Okay, so functions, we'll be using a lot of functions and modules as we proceed with our labs for machine learning, because most of these functions will just be containing a lot of blocks of code that can be used again and again. Right, so for functions, there are many kind of functions in the Python, but here we're going to focus on the built-in functions and the user-defined functions, because we'll be using this a lot. Okay, so Python has a lot of built-in functions that you can use, for example, without doing any imports. So you have a lot of these mathematical functions. We have conversion functions, and then we have the data structure functions. Okay, so let's take an example of using, say, the data structure functions. For example, we want to calculate, say, we want to get the maximum, the minimum, or even the length of the data type, or even we want to do some operations such as sum. Right, let's again look at an example of elevation. So you have elevation, and say we want to get the maximum value, the maximum elevation here. Okay, we can just use this inbuilt function, this max. Okay, this is inbuilt functions. If we run this, we are going to get the maximum elevation. Okay, we can also do that for finding the minimum elevation. We can use the minimum function. So again, if you see, this is a built-in function. Okay, built-in function min. And for the length also, we want to get the length of the number of items in this variable. Again, we can just run the length, and also we have the sum. We can get the sum For example, calculate the average again. We can call in sum. So elevation over total location, and then we can do this calculation. So if we run here, we can get the highest elevation. Okay, this is from the max inbuilt function. The lowest elevation is from minimum, and the number of locations, it's counting the number of locations. This is elevation, and then the sum help us to calculate the average elevation. Right. Okay, then we also have the user-defined functions. Okay, so the user-defined functions here these are the functions that you define yourself, so that you can perform specific tasks in Python. For example, we want to calculate the area of a given plot. So here we can create our own function. And please take note, when you define the function, you just start with this def, okay? And then we say we want to calculate the area of our function is calculate the area of a given place in square meters. Right, and if we now give the quantity of say the length of the plot and the width of the plot, and then we call in the function, and then we put in the plot and width, we will be able to calculate the area of the plot. So here is 1,500 square meters. Okay, so this is an important thing that you need to really understand, because functions, you'll be using them a lot as you progress in your programming, especially with languages like Python. Right. Next, we want to look at some of the modules. Okay, so also Python has a lot of modules that again use to organize and reuse code. So a module is just a file that contains Python code. It can also include functions, classes, and variables. Okay, we have some of the modules, for example, such as math, OS, and datetime, which are available in functions, as well as other third-party modules. Right. Here we have an example of the math module, which contains the radians used to convert degrees to radians, the sine and cosine. These are trigonometric functions. And we have the square root to calculate the square root, and then to compute the angle in radians. Okay, so this is just a simple example. We want to calculate distance between two coordinates. Okay, so remember the coordinates, they are in degrees, but when we want to measure the distance, we want to measure the distance in kilometers. So the example here is for measuring distance between two cities, and we are only given the location of the points in geographic coordinates. Okay, right. So this is just a function which uses the math module in order to do the calculation. So we are just taking in from the math module, we are using radians and sine and the others to do the calculation. So we are simply creating the calculate distance function, which takes in the latitude and longitudes from two different locations, and then we do the conversions, and using the Haversine formula we can do the calculation. And then next is just plugging in the geographic coordinates of 2 points. So here the city of Harare and Bulawayo, and then we do the calculation, and if we run we can see the distance is 364 and 364 kilometers. So you can plug in any geographic coordinates of 2 points, and then you can use this function and the built-in modules again and again to run to do your calculations. Right, and then next we have the library. So libraries are quite important. Okay, so these are a collection of modules which are packed together to provide a specific set of functionalities. Okay, so modules are very, very important. Here we will be using a lot of modules in Python. The libraries, we are going to use a lot of libraries in Python, so which contains many modules. So libraries can contain a few modules to hundreds of them. And this is quite important because you can use modules without writing code from scratch. Okay, so for example, we are going to use a lot of the GeoPandas modules. We are going to use a lot of modules that creates, for example, the GeoPandas library. We are going to use a lot of these libraries, such as scikit-learn for machine learning. We are going to use libraries for manipulating raster. Okay, for example, rasterio, ethpy. So the libraries are very, very important. Right, just an example here, we are going to use the NumPy library to do a calculation, simple calculation, just to calculate the average elevation. So here we have an array of the elevation, and next we just call the mean, which comes from the NumPy library. So if we run this code, we get our average. Okay, so we will talk a lot about libraries again, because these are quite important as we progress with our programming. Right, so just the important things, some of the best practices for using functions and modules, and please use the descriptive names for functions and modules. And it is also important to write the docstrings to describe what the function or module does, and avoid circular imports by structuring the code logically. So this is quite important for efficiency. And reuse and modularize code into smaller modules for better readability and maintainability. So this is quite important if you want to share the code with others. And mastering function modules is very important because it can enable you to build scalable and efficient applications in Python. Okay, so this is just a basic introduction to Python programming, and we are going to be using some of these things that we have learned today as we progress with our courses and modules. So thank you very much for watching this video tutorial. See you in the next one.